Hello, everyone. Welcome back here. Happy Tuesday to you. Can you please give me a thumbs up if you can hear me and see me? All right, wonderful. So I'm going to share my screen now. If you can give me another thumbs up if you can see the slides. All right, excellent. So just give me a brief moment to go check on something and I will come back. Alrighty, folks, I'm back here. So let's just start the conversation about design patterns. This is lecture 2 on the design patterns. And last lecture, we talked about what design patterns are. Here is a sort of a fabricated definition. A design pattern is a proven, reusable solution to a commonly occurring problem. And we built on that definition and said that the Gang of Four, with their famous classic design patterns book, they categorized the patterns into three big groups. They're the structural patterns, creational patterns, and behavioral patterns. And so each one of these categories are basically concerning a different aspect of your design. For example, the structural patterns talking about how you would organize your classes and objects. Um, and I promise you that we're going to see a few examples of each of these categories. So what we're going to aim for is to visit at least two patterns from each category. And we've already talked about the composite pattern, which is a structural pattern. And today we're going to be talking about another 5 design patterns. And we're not going to do a exhaustive analysis of these patterns, so we will be able to cover all of them in one lecture. But let's start with a review of the composite pattern. So the definition of a pattern was that it provides a means of grouping together several objects that are several objects of type T such that the grouped object is also of type T. I'm hearing a little bit of an echo back here in class. If you can please turn off your microphone and give me a moment to close my window here too. There's a bit of a noise from outside. Sorry about that. Alrighty. Okay, so we've been talking about the composite pattern, and it essentially allows you to group together several objects and also consider the aggregate as the same type as the component one. An example of that was the shape, and uh, when we wanted to have different kinds of shape and then combine and group those shape together and then treat the grouped one, the composite shape, as a shape in its own right. And this is a UML diagram that corresponds to this design pattern. So you typically have an interface that represents an individual component. This would be in the context of our example, the shape interface, and then you have several concrete implementation of that interface. So these concrete components, they could be things like circle, rectangle, a square, and so on. And then you have the composite, which is essentially your shape group in the context of that example. And the trick here really is that you have a, a composition, so you have a hazard relationship here, and at the same time you have implementation is a relationship. And this little trick allows you to essentially create nested groups and to treat the aggregate object as a unit of that component. So the next design pattern that I want to talk about is the adapter pattern. And this one is a structural design pattern that allows objects with incompatible interfaces to collaborate with one another. So let me explain this pattern using an example from the other course that I'm teaching, data structures. And I know a lot of you have taken that course because it was a prerequisite for OOSE. And so if you remember, one of the homeworks was about implementing a supremely simple search engine, which we called it Jugo. And if you've never taken that class, that's okay too. We just want to reflect on a partial design of that application. So in the data structure course, we had a map interface. And that map interface was slightly different from the map interface that comes with Java. Namely, one of those differences is that we had two different methods, insert and put. And the distinction between the two is that you use insert to insert new key value pairs, but you use put to update an existing key value pair. On the other hand, the map interface in Java only has a single put method, and it does the job of both of these insert and put method in our made up map interface. Then we had this application, Jugo, which was a search engine, and it was using a hash table, an implementation of map, to basically store data and index some information that we were going to search over it. Now imagine that that course is over and you want to go ahead and use an implementation of map that comes with JDK, because while it's probably more efficient, faster, but in order to do that, if you're going to directly change the code in Jugo, you have to be very careful about how you use the put method. And it's a little tricky. I mean, you can go and maybe try to replace everywhere that you use the word insert and change it to put, but it's potentially a risky thing to do. You might end up breaking something in your code. So when you have a situation like this, essentially you want to use some existing class, like a hash map in Java's API that implements Java's map. But its interface is not quite compatible with the rest of your code. Then you're going to go and use the adapter pattern. And an adapter does something like this. So it says, hey, go ahead, make a new implementation of the interface that you already have. But inside that implementation, basically make a mapping, make a wrapper class for the other existing code, like a hash map in Java that you want to be using. So if you look at the code for this design, it will look something like this. So I have this JDK map adapter that implements our map class. But inside of it, it actually uses the map from Java and a concrete implementation of that map in Java. And so another name for a class like this is a wrapper class, because it essentially all the operation that are going to be implemented here are delegating their responsibility to the similar or related operations inside the Java's map. So then the implementation of insert would look something like this. You would check, for example, if the map already contains that key, you would throw an exception, because based on the definition of the insert, you only want to use it when you add a new key value pair. And for the put, then you explicitly check to make sure that your map does contain that key, because the job of it is to actually update a given key that already exists in your map. And if that's not the case, then you throw an exception. So by doing something like this, you can easily plug in, so to speak, without making really any changes to your application, um, a piece of a code that was not really completely compatible with how your application was put in place. And as an aside, when you look at this design diagram, I want to bring your attention that it also follows the dependency inversion principle. There is an abstraction that is introduced between high-level classes and low-level classes. So the general idea of adapter class is actually very similar to adapter in physical world, right? Think of a mobile charger as an adapter. Like the mobile battery needs, I don't know, something between 5 to 18 volts to charge, but the normal socket produces 120 volt here in US, or 220 like in Europe. So the charger works as an adapter between the mobile charging socket and the wall socket. And that's really why this class, the JDK map adapter, is called adapter, because it sort of works as a as an intermediate between the map interface that you have and this other hash map class that's already implemented in Java's JDK. So the advantage of using this pattern is that you don't really need to change the existing class or the interface. So no need to change the RMap interface, no need to change the hash map class that's here, and also no need to change anything in the Jugal class. And so by introducing this new class, the JDK map adapter, which acts as a bridge, as an adapter between the interface and the existing hash map, you reuse your existing code without really changing it. The next design pattern is a factory pattern. And factory is a creational design pattern, which allows you to replace direct object construction calls, the ones that you make using new keyword in Java, with calls to a special factory method. And you've seen this pattern before, especially when we were working with JDBC API. So if you remember, we had, here's a very simple example of it. You wanted to connect to a SQLite database. You would create a connection object, but if you notice, we never said connection con is equal to new connection. So we didn't directly instantiate this object, this class. Connection is actually an interface, but anyhow, we didn't really instantiate any concrete implementation of connection. What we did instead was to call driver manager.getConnection, and we provided that with this universal resource identifier, which is a string formatted in a specific way that makes sense to that getConnection method. So then the diagram for it would look like this. You have this interface connection, and then you have the driver manager class with a method called getConnection that basically creates this connection for you. So the driver manager is a factory. The getConnection method is a factory method. So why would we want this? Why not use a constructor to make a connection object? So let's actually keep it on this slide, and then I'll move on with the example. So under the hood, what driver manager does is that when you give it this particular URI, it will find the SQLite driver by looking at this part of the URI. It knows that you're looking for SQLite. So it finds that driver, and it calls the connect method of the SQLite driver, which in turn will return a concrete implementation of connection class. So the people who, let's say, create and maintain SQLite, they are supposed to provide an implementation of the interfaces in JDBC, and so they will implement connection in a way that it would allow you to actually connect to a SQLite database and start working with it. And so the job of this driver manager get connection is to go and instantiate the right object for you. And so this eliminates the need for you to specify the concrete implementation of the connection in your code. So imagine if we wanted to do that, what would have been a problem? Well, we might have had a code that looked like this. So connection con equal to new SQLite connection. Now, I don't even know if this is really a class in the SQLite database. I'm just making this up right now. But if I were to design it, I probably would make a class like this that would be an implementation of connection. And I also don't know if this imaginary class really takes this argument in or not. But I'm just imagining it would be something like this. And so we could write code like this, but this requires us to actually know about the existence of this class, to actually know that how it behaves, what kind of input it has. So beside the fact that we have to have that knowledge to be able to use it, the code is also, it has a dependency on this concrete implementation. Like if I'm using this type, I'm going to have an import statement up in my code that basically imports that type. But if you look at the previous implementation, all I really need to provide is this URI string. And I can write my code against the general, all the packages, all the classes that are in the SQL package that comes with Java. So so the other advantage of it is that then when you run this code, you can actually change this string during the runtime. And because the get connection will take care of actually establishing the connection for you, that change will not have any manifestation in the code. So this allows you to, during the runtime, actually change the database to some other databases or some other methods or some other files or something like that. Whereas if I were to go down the road of using a concrete implementation, for every different implementation, I have to come back here, update my code, change the import statements. So it makes for a cleaner implementation. It's a lot easier to sort of plug and play with other databases in here. And so the client code does not need to decide which implementation to make, and therefore it's not really coupled to it. So that's really the big idea of using a factory pattern, and it's especially very common when you want to create a library or a framework. Um, because that at the time that you create your library, you don't even know how other clients or other frameworks that are adapting yours are going to extend your classes or implement your classes. So the pattern removes the need for instantiating actual implementation classes from the client code, and it also makes your code to be less coupled and easier to extend and in a way more robust. So this is a very common pattern. In fact, it's quite used extensively. And here's just one more example to see again with the JDBC library. The driver manager, the get connection is a factory method. When you go and create a statement, you also use the create a statement, which is another factory method. And just note here how many import statement and how many dependency you needed to have, because if you wanted to specifically work with SQLite database, then you needed to use an implementation of that database for the connection interface. You needed to use an implementation of the statement class here. And this code, the more things you add in this code, the more your code becomes coupled to the particular implementation of JDBC, which in this case is SQLite. But here, everything I'm coding, I'm really coding all of them against the interfaces defined in the SQL package. All of them are implemented against the interfaces in SQL package. And all you need to do is just to change this URI. And you change that from SQLite to, let's say, PostgreSQL, and there you go. No need to change any other thing in your code. You change it to MongoDB, no need to change anything else in your code. So it's a supremely useful pattern, and really makes up for a very clean code, easy to update it, easy to extend it. All right. The next pattern is singleton pattern, but I think I had a question. Let me just quickly look at the chatting area. Someone asked, is this a slide on Piazza? The answer is no. Okay, you're gonna get the readings after this, as it is the culture of practice in this class. So the next design pattern is the singleton pattern. And the singleton pattern is a creational design pattern that lets you ensure a class has only one instance. And at the same time, it sort of provides you a global access point to that instance. It's a very interesting and at the same time simple implementation. Just think about it, and I elaborate more to why you may want to have only a single instance of an object. But imagine you have a class and you just want to have one object of it. How would you go about to implement that? Let's pause for a moment and think about that. So I'm going to give you a moment to think about it before I show you the actual answer. All right, so let's take a look at this code. Here's the simple way to do it. Suppose I have a class and I called it singleton. I mean, it could be any other name here. And what I'm doing here is that I have a private constructor for it. So nobody can really go and use the new keyword, excuse me, to instantiate this class. However, if you want to get an instance of it, you can call this public method and ask for the instance. And all that this instance does is that it returns the only single instance of this class that exists within that class itself. And inside this class, I'm able to call the private constructor, because anything that's private within the class is accessible to me. It's just not accessible from the outside world. So this sort of a little trick enables you to limit the number of objects that you have from a particular class. Now, there are going to be cases that it makes sense to have only one instance of an object. And so here is one example of it. For example, in Java's JDK, we have a class called runtime that allows the application uh, to interface with the environment, so to speak. So when your app is running, you can get the runtime, get like how much memory you've been using. But for that application, for this class, the runtime, it only makes sense to have one instance of it. If you have multiple instances of it, then you have essentially multiple sources of truth, and so you might mess up kind of looking up and trying to sort of flag down the starting point of profiling your application and the end time of profiling your application. So the runtime class in JDK has a method called get runtime. So its constructor is private. You're not going to be able to go and write runtime equal to new runtime. You have to call this method, the static method that returns the only instance of runtime. And once you essentially got that only instance, then there are different methods that you can use in there. So here the snippet that you see on this slide is basically looking at the available memory that you have before you run an application, and then it will look at the available memory that you have after you run the application. And so you subtract these two, and that you can attribute the result to the amount of memory that was used by your application. So that's a simple example of a singleton pattern. So you want to use this pattern when a class in your program should have just a single instance available to all its clients. And other examples, again, this is a very common pattern. So the other examples that you can think of, when you're working with databases, you probably want to have only a single object of a database shared by different parts of your program. If you're working with hardware, the drivers of hardware, the objects associated with the drivers, you want to have a single instance of those drivers. If you are logging something about your application, you want to have a single source of truths. Like you should really just have one logging object, so everything gets logged through that object. So there are a lot of different situations that you might need a singleton pattern. And again, the advantage of using it is that, well, it allows you to have only a single instance, and you gain a sort of a global access point to that instance. I just want to make a point that generally speaking, when we talk about anything that's global, people usually remember global variables, and you're probably told that they're bad and unsafe, and you should not be using them, and all of that argument is valid and it makes sense. But really, the singleton is not like a global variable that are unsafe, because with global variables, the reason they're unsafe is that any code can potentially override their content, and because of that, you don't have enough control over it. It's hard to debug it. It's hard to track it, and some parts of the client code might override it, and it would result in a crash in other parts of your application. But the singleton pattern actually allows you to safely access some object from anywhere, because that single global instance is private, and it's within the singleton object itself. So it sort of protects the only single instance from being overwritten by other code. Um, so let me look at the questions. There's a question that says, why don't we just call the methods using the class name directly? I'm not sure what this question is referencing to, but if it's about the slide that we see, these methods are not static, so you're not going to be able to directly access them. Um, and the choice of making methods static depend on what you're doing with the application. If you require to instantiate objects, and especially have an instance um, of your object, then you're not going to be able to have a static methods in there. Um, okay. So let's talk about another design pattern. This one is an iterator. So the iterator pattern is a behavioral pattern that allows you to traverse a collection of objects without exposing the underlying representation. And this is again a very popular pattern. It's especially useful and it's extensively used with Java collections. So all of those data structures, like if you have a list, a stack, a tree, a map, it allows you for an easy way from the perspective of a client to go over the elements that are stored in that collection. And you don't need to worry about how the elements are stored, or worrying about how you actually should go and iterate over the elements. So here's a very simple example. Um, I have created a tree set object, which is an implementation of the ordered set. So the elements that are stored in tree set are going to be sorted in ascending order. And you can easily iterate over it. So this loop, which sometimes called for each loop, um, Java's document officially calls this an enhanced loop. Um, it allows you to go over the elements that you have stored, and irrespective of the order that you have inserted them, it is guaranteed that you will get them out in the sorted order. So as a client, you don't need to worry about how to store them. You don't need to worry about how to navigate them. Uh, um, and you can think of a more complex situation. If you have taken data structure course with us, you've implemented this pattern pretty much for every data structure you've implemented in that class. And so if this was a tree, uh, then you might recall that you have different ways of traversing a tree: level order traversal, the pre-order, post-order, in-order, and the algorithm and the implementation of those algorithms may actually not be trivial, which in many cases they aren't. And so you take this responsibility on yourself, and the client only simply asks for an iterator to iterate over the collection. And this snippet of code, the enhanced for loop, is really syntax sugar for what you see here on the slide. So what essentially you're doing is you're getting an iterator from the object that you've created, and then that iterator has at least these two methods implemented. There is a method called hasNext, which tells you that whether there is another element yet left in the collection that you have not explored. And then there is a next method that gives you the next element that you haven't explored. And so the combination of these two essentially allows you to iterate over that collection. So the diagram for this design pattern, if it's implemented in Java, will look like this. You have a collection that needs to be iterated over, and the interface, it's called iterable. So anything that implements iterable needs to provide this iterator method. And so users can use that method to get an iterator. And then iterator has these two methods. And so when you build a collection, you also have to build the iterator for that collection. And there are a couple of interesting points that I want to make about this diagram. So one of them is that if you see, pay attention to the bottom of the diagram, this is an association. And this symbol here, it shows that tree set iterator is a class that is placed inside tree set class. So that's a common practice that you do separate the implementation of iterators from the collection itself. That's in line with the single responsibility principle. But at the same time, you often place this class as a nested inner class inside the collection class itself. And that has more technical reason than the design decision. It allows you to directly access the private elements of the tree set, and that's really useful for implementation of the iterator. Um, the other nice thing is pay attention to the use of the iterable. So iterable is a very skinny interface. It just has one method in it. Well, after Java started being functional, there were a few more methods added in here, but essentially this is the one that you must implement. And this is in line with the interface segregation principle. You look at the iterator interface, and you notice that we have this interface, and we provide a specific implementation for the iterator here. This is in line with the open close principle, because you can you can implement multiple different iterators for a collection. For example, for example, if you're working with the tree set, and let's say you want to get the elements in reverse order instead of in the natural ascending order. So you want to get them in descending order. It's very easy to do that. You're not going to be able to do it with the for each loop. That's tuned to use the default iterator. But you can go in the second code snippet that you see here, and on the first line, you can change that to set. and then ask for descending iterator. The method is called exactly that, two words, camel case. And you don't need to make any other changes to the rest of your code. And what will happen is that you'll end up printing out the elements in the descending order. So to summarize, you want to use the iterator pattern when your application has collection objects, especially when the collection is some sort of a complex data structure. And you want to hide its complexity from the clients. Now, either you want to do that for convenience, so that it's easier on them to navigate your collection, or for security reason, you don't want to expose how your aggregate type, your data structure is represented under the hood. And the advantage of it is that the iterator pattern, it hides the actual implementation of the traversal. And so the client programs can simply use the iterator method as a means of going over every element in your collection. All right, so let us talk about the observer pattern now. This is the last pattern I'm going to talk about today. So observer is a behavioral design pattern. It lets you define a sort of a subscription mechanism to notify multiple objects about any events that happen to an object that you're observing. So what does that really mean? I'm going to use an example that's probably relevant given the current COVID-19 crisis. Now, suppose you're interested in purchasing disinfecting wipes, but they're out of stock, and that's really the case right now, at least for me. And so you would want to keep an eye out for when it becomes available again. So this is what I'm doing. Honestly, I'm routinely checking the stocks now. Either I visit some local stores around me. I go on Amazon and see if they become available. So um, this process, it actually requires significant time, commitment, and effort on your side. And a better strategy, something I wish I could do, was to subscribe if that option is available to a provider subscription service, and then ask to be notified uh, when the item that I'm interested becomes available, it becomes in stock again. So this model of sort of a subscribing to a provider and then receiving notification when something happens. This is the underlying idea behind the observer pattern. Um, in some references is also called publish subscribe pattern. It essentially allows you to get notified whenever there is a change in the state of an object you're interested in. So let's turn this over again, move it back to programming. So the object that you watch, the object that watches the state of another object, called the observer or subscriber, and the object that is being watched is called the subject or observable. Uh, the pattern is very popular. It's especially widely used in all graphical user interfaces, all the GUI components. And if you've ever done GUI development, you're familiar with the event-driven programming. So you have these things called action event listeners. And the idea of it is like, let's say I have a button on a form, and then when you click that button, something must happen. And so a click is an event. And when you implement it, you need to implement quote unquote an event listener, where the event is a click. And so whenever that event happens, an action will be triggered by the event listener that you have created. So bringing that back into the language of observer pattern, each GUI component is a subject, where different events like clicking on something would send a notification to an observer class. And your observer class is an event listener essentially. It's probably, if you're doing it in a model view controller, is part of a controller. And then that event listener would perform different actions based on the occurrence of a particular event. So in Java, of course, you have the event listener mechanism in, for example, if you use the Swing framework for developing GUI application. The more sort of a plain way of implementing the observer pattern is through the observable class and the observer interface. So these two things, they come shipped with the Java JDK. And the observable class essentially is the subject of your observation. And it has several methods, namely these two methods. So you can add observers, and then you can call notify observers when an event happens. So any class that you would consider the publisher. So here, for example, let's say Amazon, the website, or any online store, that's the one that you want to observe. It would allow you to add yourself as a subscriber. So there must be a method or part of the interface that you can go and sign up, and that would call this add observer method, and then you will be added to a list, to a collection of observers. And the class that represents you should implement the observer interface. And then when something becomes available, when publisher wants to notify the observers, let's say the wipes are available now, you want to send out notification, then the publisher will just call notify observers and maybe provide a message or something in there. And then notify observer is simply has a loop in it that goes over the list of all the observers and call the update method on them. So as a class that represents you, the subscriber, it's your responsibility to implement the update. Meaning that when you receive the notification, it's up to you that what you want to do with that notification. Now, either you want to delete that email, or you want to go and purchase the item that became available, or I don't know, you want to do whatever. But that's essentially the model. Now, one other thing that's probably worth mentioning here is that, funny enough, these two, the observable class and the observer interface, they've been depreciated I think after Java 9 or Java 10. And so if you now go and try to actually use these, depending on your IDE and like the settings of your project, like what language level you're using, you're probably going to get like a line crossing over the type, and a warning that says these are depreciated. And depreciated means that the organization behind maintaining and developing Java said that, hey, we're not going to continue maintaining these classes, and potentially at some future point they may be removed from SDK. And so it's like you're taking a risk if you're using them. Uh, I want to bring up this point because it's very important that you understand this does not mean the observer pattern is depreciated. The pattern is extremely useful. You find it all over the place. It's just that this particular implementation of the pattern in Java was not ideal. Like the observable is a class. If you're extending a class, you know any class in Java can potentially just extend one other class. If you're extending this, you're basically burning the chance to extend any other type in there. So that's a problem. Would have been better if this was an interface. A the order of which that you update the observers is not specified. You can't control over that, so that creates some issues when you have multi-threaded application. The observable class was not implementing serializable, so if you want to create persistence of this type, it's going to be a little bit of a problem. And generally speaking, the event model here was limited. Uh, they decided that essentially it's not worth making updating this and moving forward with it because of the issues that this particular implementation had. So the case in point is that if you're a Java developer and you want to consider implementing this pattern, then you either want to do this on your own, so create these interfaces for yourself. They're very skinny and simple. You can do it on your own, or there are other mechanisms in Java that you can use for having similar notification models, like Java introduced in Java 10, I think Java Beans, and that has a notification model incorporated in it. So you can use that model instead. Okay, so what I want to do now is to go and actually show you how this pattern you can implement it. Um, so I have a sample example here, and I will give you this code after the lecture, so you can go ahead and play with it. Um, the code that I have here is a very simple implementation of the game of Space Invaders. So I'm going to show you how you can play it, and then uh, uh, oh, it doesn't show up here. Let me stop this for a moment and try to do this again. So I'm gonna stop sharing for a moment. I need to put this on my other monitor to be able to do this essentially. So give me a brief moment to set this up for you. Okay. We can probably do it now. Let's take a look at this. Can you give me a thumbs up if you can see this application? Okay. So that's my very simple implementation of the Space Invaders. And so the orange thing is a tank, the blue things are invaders, and the red things are my missiles. And so the goal is to basically destroy those invaders before they manage to land. And I think I'm about to lose the game. Damn. Yeah, I lost it. Not generally good at games. Anyway, so let's take a look at the code, and so let me get out of this and look at the code now. Can you see my IntelliJ? Can you give me thumbs up if you can see my IntelliJ? All right, thank you. So the model, the implementation conforms to the model view controller. So looking at the model, you basically have these classes, an invader, missile, a tank, and a sprite, which essentially a missile is implementing it. Then you have views. So the view has the game panel. Now, if we run this one more time, I can probably elaborate a little better. So the area that is dark gray, that's the game panel. So this is like the space, so to speak, when you have your tank, the invaders and the missiles, and then on top of it you have this sort of a light gray bar, and that panel up there that shows you information about invaders shot down and missiles remaining. That's what I call the game panel. And then the application is the thing that puts these two together, essentially. So that's the main window, so to speak. And then you have a controller that implements the logic of the Space Invaders game. So like when you press a key, what should happen? How would you initialize the game? How would you fire the missiles? Like check for collisions, whether game is over or not. So all of that logic, the logic of the game, that all comes into the controller. And then you have this driver class, the play. It's very simple. It just instantiate the application, which is this big the main framework here. So what I want to do is to essentially bring your attention to the way the application here is implemented. If you look at inside the application class, we have a timer. And so this timer, what it does, and timer is a built-in class in Java. So you can give it an interval and say over those interval, go ahead and perform an action. And so the action is also tied to an event. And so any event that happens within the game, and this event is a very general sense of an event. That means that since we're playing the game using the keyboard, any key that you press on your keyboard, it essentially triggers an event here. And so when that happened, you update the game. So you ask your controller to essentially update the state of the game, to count again, like how many missiles you have left, how many invaders are down, or whether the game ended, like you lost the game or something like that. So that happens, and then you ask the game panel to repaint itself. So that's the sort of the dark space, the dark gray area. So you're gonna see sort of, because it happens over the short interval, you kind of see it like on like a live action. And then the other thing is that you have this a, a score panel, which is over the top here, and you ask that to update itself. And so this is in a way one way to adhere to the observer design pattern, because it uses action listener, right? So every time an action happens, these things gets updated. What we want to do now is to go ahead and try to update the score panel only when a specific event happen in a game that warrants an update to the score panel. So I should not, for example, attempt to update this like when I'm pressing any key on my keyboard, or when I'm just moving around, moving my tanker around. It should only get updated when I fire missile and when an invader gets destroyed. So these are the two events that that should trigger an update on a score panel. So this is what I want to do. And the first thing I will do, and I want to do it using the observer observable in Java to just show you how this can be done. So the first thing is I'm going to take this line out. And if I run the code again, I just want to confirm that right now, if I go around and fire missiles and kill an invader or something like that, I'm out of missiles. Okay. You see, I fired a lot of missiles and killed an invader, but nothing got updated in the score panel up there. All right, so now let's go and try to incorporate the observer observable in here. So the first thing you need to do is to recognize what is or who are your observers and what is the subject of that observation. So obviously the observer is the score panel. So you can go in a score panel and say, well, the score panel implements observer. And so you can see this is unhappy here. And I'm just going to make sure that my uh, language level is on 8 so I can continue using it. And it's glossed over because it's depreciated. So it says that this is depreciated. But at the same time, when you implement that interface, you have to implement its only method, which is update. So I'm going to have this update method, and right now I'm going to be doing this lame thing of calling the other update method. So just call the other update method, and that will set the text for the two labels for the number of invaders and the number of missiles, and then trigger a repaint to basically display it. The next thing is to recognize what is the subject of observation. Well, the subject of observation is the state of game, and the class that is sort of in control of the state of game that keeps count of that is the Space Invader class. So this is the class that's going to be extending observable. So this extends observable. And now what we need to do is to think about what are the events that we need to send notification to our observers. So there are a lot of methods in this class, and essentially any of those methods that are going to update the number of missiles or the number of invaders, they need to be considered as a trigger point to trigger a notification. So here, for example, the reset resets the number of missiles and number of invaders to 0. So I have to call the methods that are part of the observable class. So the methods, there's a notify observers method. And on top of the notify observers method, you have to say set changed for this, so the combination of this, it essentially says that something changed, and then it says, okay, notify the observers. And then when notification is done, internally, the observable class will change that set change flag back to what it was before. So I kind of need to do these two statements at every point that I want to send notification. Initialize sprites. I'm not sure if this is, so I'll look at that later. Fire missiles, definitely I'm changing the number of missiles, so that's a place to do this. Check missiles, so this basically checks if a missile had gone out of the screen. And so that's definitely a place that I want to notify my observer. Invade, so it generates new invaders. Well, I'm not sure if that's the right place to do it. Check for collisions. That probably is a right place to do that, because when an invader gets hit, you want to update the score panel. But I do have a method specific for that that changes the number of missile and invaders. So I can go add that in there and check if game is over. When you initialize the sprites again, you probably want to update your observers. So now that I have identified all my trigger points and put the uh, call to notify observer in there, what I need to do is to make sure that a Space Invader game knows that a score panel is one of its observers. So for that, I'm going to go inside the application framework that essentially instantiate all these objects. So I have a Space Invader game, I have a game panel, I have a score panel, and this is the constructor of it. So maybe as soon as the score panel is instantiated, I can go and say game add observer and then put the score panel to it. So um, so now I think if we run the code, you can see when I fire a missile now again I can see the things gets updated, uh, and so the invaders also, the value gets updated in there. Um, so one nice thing about going down this road is that if I go inside and take a look at the score panel, you can see that the panel actually has a dependency on the Space Invader game, because it sort of needs this to get information about what are the current number of invaders that are destroyed, or the number of missiles that are left. So uh, what I can do is to remove this dependency and actually change it into a sort of a looser kind of a dependency. I can try to take this out. So I don't really need to use this argument anymore. And so what is this statement doing? It initializes the label for in invaders when the game starts. Well, that's just zero when we start. And then here, instead of calling update, I can take matters in my own hand. Um, so so let's make sure that this is commented out. And this is what I can do. The observer, the observer pattern in Java, the way it's implemented through observer observable is that when observable sends notification and it calls the update method of observers, it actually gives a reference to itself. So this object of observable is a reference to the subject of observation. So I can go and say the Space Invader game and basically cast that observable uh, into an object of a Space Invader game, and then directly use it, get information out of it, that the sort of information that I want to have in here. Um, so if I were to let me just run the code and make sure that everything runs. So the missiles are firing, everything is working in there. Didn't see any invader coming down. Okay, so invader came down. Let's kill that invader. And okay, so everything is good. So the point is, if I were to draw the UML diagram now, it used to be an association between a score panel and a space invader. And now I can easily remove that association because all I needed it for was to get this information. And so this is just the dependency now, which is a looser coupling compared to an association relationship. And that's sort of the idea of the observer design patterns. One of the advantages of using it, that it accounts for loosely coupled objects. So the subject knows very little about the observers other than the fact that they are implementing the observer interface. And so to sort of summarize this discussion, you want to use the observer design pattern when you have a situation that changes to a state of one object. It might require changing the state of other objects. So, you may not even know ahead of time what is that secondary set of objects. So you come up with this design of having a subject and an observer, and that allows you to later on easily extend the application by having multiple different types of observers. All right, so that sort of concludes my discussion on design patterns. There are a lot of design patterns, and we're not going to be going over all of those, and it was never in the plans for this class. But what, what we want to be doing is to make sure that we are at least familiar with the most commonly used ones. And so next lecture, what we want to be doing is to sort of prepare ourselves for the quiz, and I will send a instruction about how we will be doing that. But my plan essentially is for us to have a sort of a sample midterm and sorry, sample quiz, and I want to simulate the actual condition of the quiz. So we will be conducting it as if this was the actual quiz. We'll have proctors. We'll have you to. I will post instruction about what you need to do, and I highly encourage that every one of you take part in that practice because that makes you understand what kind of questions that you will see. So that would inform your preparation for the actual quiz. And the second thing is that it give you a practice run for all the logistics that we have to put together and make sure that it works, given that we are doing this remotely. But other than that, a big congratulations to all of you because we are technically finished with all the topics that we wanted to cover in this class. All that's left for us is to just deliver the project, and there is the small matter of the quiz. So thank you very much for attending this lecture. I'll see some of you on Thursday, and then hopefully I'll see every one of you on the coming Tuesday when we will have a practice quiz. Have a wonderful time. Stay safe out there. Goodbye.